Bias can impact the analytic process in many ways, ranging from biased data collection strategies to biased algorithmic transformations to cognitively biased analysts. Cognitive bias in particular can be injected into visual analytics systems through user interaction and propagated through or even amplified by analytic models. One potential risk is that the user creates an echo chamber rather than conducting an objective analysis of the data. Recently, Wall et al. Proposed a set of 6 computational metrics that can be applied to user interaction sequences to quantify bias in the analytic process in real time. We call these bias metrics. So, as people are interacting with a visual analytics system, these metrics should be able to pick up on potentially biased behaviors. We conducted a formative study with 2 goals: to analyze how the bias metrics could be used to capture a well-known bias, and to refine our understanding of how to implement the bias metrics in a visual analytic tool. In this case, we studied anchoring bias, the tendency for people to rely too heavily on the information initially presented. Participants were given the task of categorizing basketball players by the position they play. We divided participants randomly into 2 conditions that each described the 5 basketball positions differently. These descriptions were designed to influence participants to exhibit anchoring bias toward different attributes of the data. Participants used a modified version of an existing tool, INTERACT2019, to perform their categorization of the data. By capturing and recording users' interactions in the system to complete their task, we hope to see how anchoring bias would manifest in users' interactive behavior as described by the bias metrics. Our analysis suggests that anchoring bias effects can be observed in users' interactive behavior in a visual analytic tool, including through the lens of the computational bias metrics. Specifically, we found that when examining the sequence of bias metric values over time, participants had higher metric values for the attributes they anchored on based on their framing condition. For example, participants who were given descriptions of the basketball positions based on the physical size and stature of the players exhibited higher bias toward the height and the weight attributes than participants who were given descriptions of the basketball positions based on other attributes of the data. We also found that visualizing the coverage and distribution of data points, attributes, and attribute weights used to compute the bias metrics can be an informative way to see not only that a user is biased, but where in the distribution of the data they are focusing their attention. In addition to the qualitative results of the user study, we describe important considerations for implementing the bias metrics in a visual analytic tool based on our own lessons learned, including navigating the trade-off between designing systems to measure bias versus optimizing for usability, which interactions to include when computing the bias metrics, and how to interpret the results. Please read our paper to find out more.